Okay, Kenneth, we don't have time, so let's get this started. Hi everybody again, I'm Wolle and I'm super hyped to be here presenting What You Say is What You Get Handsfree coding in 2022. This is actually a topic that is pretty close to my heart because I am obviously dependent on other interfaces than keyboard and mouse to use my computer. And a few years ago, I have basically found a community of people who are actively engaged in developing software to make this possible. And it's so awesome that I think you should also know about this. And if you think about it, I mean, hands-free coding, what you say is what you get. It gives it away. It's mainly about voice coding, and voice coding should be simple, right? Because what do you need? You need a microphone, of course. Yeah, every notebook has a microphone. You know, we had a pandemic. Everybody has a headset or should have a headset, actually. Check. You know, then you need software that recognizes your voice. Speech recognition software has been, I think, included in Windows since Vista, 15 years or so. So everybody has that. You know, it's in Mac. Everybody has it. And then you obviously need something that executes commands. So you don't just produce text. You also want stuff to happen when you talk. But this is something that every speech recognition software also provides. So you can check that as well. I mean, you know, let's go. Okay. Funnily, there is the perfect video. Yeah, full stop. And the perfect video for illustrating how easy it is to code with your voice with the stuff that Windows gives you. And yeah, let's just watch it and talk about it later.
We're going to do a little Perl script using the Windows Vista software recognition to show you how easy it is. Open Notepad. Maximize. Open. Open parenthesis. Go to beginning of document. Delete. O. Press O. Go to end of document. Press caps lock. Info. Delete info. Press caps lock. Press caps lock. Info. Delete info. Press capital I. Delete I. Press capital I. Delete I. Press capital I. Scroll. Press caps lock. Press caps lock. Delete I scroll this conflict. I don't scroll this conflict. Delete adult scrolls conflict for. Delete adult scrolls conflict for. Delete adult scrolls conflict for. Thank you.
Okay, what happened? Before we go on, I just need to point out that this is the perfect video, but I didn't have the idea to include it. That's actually blatantly stolen from another hands-free coding talk given by Emily Shea. So please, when you're done with this conference, visit her website, go watch Emily's talk. It's awesome. But I think the point that somewhat came across is it's not that easy to talk and code with your voice. Now, where's the challenge? Because everybody uses dictation all the time, and that's pretty nice. So why is coding so difficult? The core challenge here, or the core thing basically, is that normal speech recognition software that you know is optimized for natural language. So the software takes an audio signal, extracts features, and has an acoustic model that recognizes phonemes. And on those phonemes, you have some kind of language model that basically makes an educated guess what word sequence you might have uttered there. And the assumption is that this was actually spoken language. So the model is trained on Wikipedia text or something like that. You can execute commands like press O, for example, or you can launch Notepad. Okay, but this is a special case, and you always introduce something like that with something like press or launch or open or whatever Scrubble Up one said there. Now, with voice coding, it's the other way around, because what you actually want is every time that you utter something, stuff should happen. So the default is basically everything should be a command, and only as the exception do you actually want to write an email or reply on Slack or whatever. And I personally, for example, prefix everything that I actually want to write with the word say, because that's the special case. I typically don't write, I command something. So software that you all know and use would be something like Windows Speech Recognition, Dragon Naturally Speaking. That kind of stuff is for language. And when you want to code, you need additional software. For example, frameworks like Dragonfly or Talon. And Talon is underlined here because that's the one I personally use. So the message is you can't just talk to your computer and expect that this is actually efficient or works at any rate. It's more complex. And this is what we'll be covering in this talk today. So first, I'll give you a brief introduction of myself. Then I'll give you the basics of Handsfree coding so that you have an idea of what this is and how it works. Then we'll also have usage examples and a live demo. I hope it works. Then I'll describe my own setup and also describe a no-code setup that you can try out yourself so that you can basically hands-free code yourself. And it really doesn't cost a dime, so please try it out. That's just upfront. Please do it later. Yeah, and then we'll just skip through 1,000 slides with links. You can basically click on the links later when we upload the slides, I guess. Okay, so I'm Wolle, as I said. I'm a data science prof at the University of Oldenburg, but I'm actually coming from Hamburg. So I studied there, I did my PhD there, and I met the guys from backend pretty early, and then we did research PhD stuff together and still do to this day. But obviously my focus nowadays is on research and also on giving talks, for example, on hands-free coding. But my actual expertise or field of expertise is data management. And I just want to point out that I'm explicitly not an expert in speech recognition or human-computer interaction. So this is basically a talk given from the user perspective, and you should take everything I say or show with a grain of salt. And yeah, I'm not the expert here, I'm just using stuff. Now to the stuff. When you want to do, basically control your computer without your voice, you need ways to address everything that you can do with your voice, obviously. And that means you have, for example, vocabulary to say something like press that button, do a right click, and so on. And as I said, everything is interpreted as an action command, so you wouldn't say press 1, you would just say 1, and then the 1 is pressed. And we have loads of examples on these slides, and I won't go over all of them in detail, just that you know these things should be read like this. The left side is what you say, so for example, 1 space parent bang slash, that is what you say, and then the output or what you get would be on the right, like to the right of that arrow. Yeah, so you need stuff to execute actions, type all kinds of symbols. You need for the alphabet, so for every letter, basically a precise way to tell the computer to press that button. And that's difficult because F and S sounds very much alike, and therefore you don't actually use the alphabet, but you use a spelling alphabet, like the Natter one, for example. But typically, people use optimized alphabets that don't have that many syllables because going like Alpha Bravo Charlie all the time is just super slow. Yeah, then you need navigation, for example, go left, go right to move your cursor, or go home to visit your home page in a browser or whatever. Yeah, then all kinds of typing commands for actually writing text. So as I said, say is my prefix for real spoken language. So for example, comma would be translated to the actual punctuation mark. And you can also say, no, please write exactly what you recognize. And then I would say phrase, and that would actually spell out the word comma. And you can also, and that's interesting in the context of programming, use all kinds of formatters. So for example, you can write stuff in camel case or dash case, kebab case, dotted, without space, uppercase, lowercase, whatever. You can define that stuff for yourself. And you, of course, have convenience commands like show me the history of recognition so that you know what the thing understood, because sometimes misrecognitions lead to pretty random behavior, and it's important to understand what the hell just happened. So you need to look up what the thing understood or thought you were talking about. And you can also launch applications. And I think one thing that is pretty complex to really get natural at, but is important to just know that it's there, is command chaining. So as you can see at the bottom, there is the example, parent, close parent, go left, say hi, and that produces the output on the right. And this is actually not a single command, it's a chain of commands, because sometimes you just have to basically pipeline your thoughts and get them out at once, because the software doesn't do stuff continuously, but rather waits for the end of the utterance and then does everything at once. So the command example here would first write the opening and closing parenthesis, or parent is the open parent, close parent is the other one. Then go left would move the cursor left once, and then say hi would write the word hi. So, and this is something where you really have to just use it a ton to do this efficiently and get natural with it. And the last base slide basically is this one, because I think another concept that you need to understand is dynamic scripting, in the sense that you can update your voice grammar with your voice grammar, because all the frameworks that I know are based on Python, and you can therefore basically change commands or create new commands as you go and use them right away. And that always gives me this Inception kind of feeling, because you do stuff with the stuff that you do stuff with, and it works like a charm. For example, if you have a word, for example, etc., and you think, oh, nobody writes like that long, and then you can just update a rule to say, okay, every time I say etc., please write the abbreviated version. Or you could also adjust fine-tuning, like latency settings, whatever, and it just takes effect right away. And this is the exciting moment where we try the live demo part. So stay with me. I tried this at home 1,000 times, but my setup is quite different. So I hope you can now see my PowerPoint. And now you see IntelliJ. Is that accurate? Nice. Okay, what you see here is, basically a Talon file. So something where I can create behavior. And at the top of the file, you see mode:sleep. That just means that this rule set, which I can create here, is only active in sleep mode currently, and that's what you see on the top right. Talon is completely turned off, so that nothing happens when I'm talking to you. But I will now enable it, and then I will put it to sleep. Snore. Oh. The nice sound here indicates that it's put to sleep, and this is important for myself because I'm completely wireless and I'm moving through the house and still having headsets and everything on. And it's important for me to know when Talon suddenly turns off by accident or on. And when it turns on, it makes an even nastier noise that you will hear in a few seconds when I do the live demo part. So we all know that it's on. Okay. Now what I'll do is I will create a rule for the command hello code.talks. And as you can see, when I say hello code.talks, nothing happens. And now I will demonstrate how to dynamically script a rule for that. Chirp. Chirp. Say hello code.talks. Colon space, double quote, say this is a demo command. Go down. Go left third, go before go left, kill third, word demo. Go down, save that, snore. So now we created a command on the left-hand side of the colon. You see the command, and on the right-hand side, the double quotes basically tell Talon to type that stuff. So when I say hello code.talks, et voila, we now have a working command. And you can also update that and make it more complex. Like so, for example, chirp, mark up, kill fifth, enter, space, space, word key, parent, close parent, go left, word down, go right, enter, double quote, saying now the command is executing a sequence of actions. Save that. What did kill? Snore. Did I save? I don't know. Let's try it out. what it may be doing now, given that I might have saved, it will first press the down button and then it will write the new command. Hello code.talks. Amazing. Okay, yeah, that was lame, but it was the live demo. So you can't sue me. I gave you a live demo. Now we will continue with the talk. Thank you, thank you. I know what I'm doing. Whew. Okay, the rest of the talk is mostly videos, so easy going. This was the backup video, which we don't need, of course. Okay, now this was basically just controlling your computer with your voice, but you're here for hands-free coding, so let's talk about coding. The cool thing is that you can basically define rules that are even more complex than the one I just showed you. So for example, you can have stuff like funky test func. There, funky would be the word for please create a function, and test func would be the name. And when you're in a C# file, that might result in an output like what you see on the right there, like private void test func. But when you're in a JavaScript file, the syntax might be different. You know, you might be actually wanting a different output, and Talon realizes the context in which you're in and produces different output in that context. And this is just a simple example, but you can basically map that to other scenarios. For example, when I use my IDE and I want to run the code that I'm currently developing, I just say run code. And then it runs the code because under the hood, it executes, I don't know, like Shift F10 or whatever. I don't know. I don't care because I don't have to remember this. I only have to remember that when I want to run code, I have to say run code. That's semantically relevant in the task that I am in. And that's super cool because it makes you use features that you wouldn't ever use because, frankly, you can't remember the key combinations. And this is just awesome because hands-free coding gives you an abstraction layer that basically superpowers your macros. And speaking of macros, you can also define very powerful macros that are really smart because you can use Python code in there. So, for example, I have to write LaTeX code a lot for research papers and stuff. And if you've ever written LaTeX, it's just cancer. You just want to insert a figure and it's like 20 lines of code. And instead of continuously reloading Stack Overflow pages, you can just create a template for floating figures or for tabular environments or whatever. And then you just say insert figure, and the thing just gives you the code and you don't have to remember anything. And that's awesome. And now we want to really see awesome people program, and I'm not really good at programming. So I've brought a few videos just to show you how it might look when you're actually coding with this. So check this example out.
Slap second, go up. Styled button wrapper. Blank rule background color. Color variable primary. Slap. Blank rule font size. 2 red each made. Slap. Rule cursor pointer. Rule color white. Say return. Space. Elm wrapper. Enter. Go up second and go left third. Brace space. Say children. Go down second. Brace say children. Save. Go up second. Slap second go up. Import component icon. Say icon, comma space. Closed elm icon. Squiggly attribute icon. Say icon. Save.
Yeah, so basically, I think you could argue that this is not significantly slower than doing it by hand. At any rate, it's competitive. You can actually work with that and earn your money by programming without ever touching a keyboard. And I think this is cool. And by the way, you also might have noticed that the guy was doing all the time and stuff started to zoom. That was because he, in his setup, combined everything with an eye tracker and with noise recognition, which we'll also come to in a second. But currently we're at hands-free coding, so let's talk about that a bit more. The stuff that you've seen so far is basically someone vamped up their programming grammar so that they can say something like, I don't know, rule blah, 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 and then stuff happens with colons and symbols being inserted somewhere. But you can also basically include that functionality or vamp up your IDE. And a very good example, and I think I saw it on Hacker News like last week or so, is cursorless. And that's an extension for VS Code that basically is a spoken language for structural editing. So when you are using cursorless, that's basically an extension to VS Code, so your IDE, that decorates every code token, like statements, function calls, arguments, that kind of stuff, with marks. And then you can basically select those tokens by providing a function and the mark that you see. Like, for example, function R, if the thing is marked with an R. And then you can invoke actions on those tokens. So you can basically move stuff around or delete functions or create functions or whatever. And just as an example, such a command could be chuck func red, and that translates to delete the function marked with R, because chuck is the action for deleting stuff, func is the scope for function, or state would be statement, this along those lines, and red is basically voice coding speak for the letter R. So also, again, a live demo just to see how that looks in practice.
To, let's say, just insert this function call at the cursor, I could just say, bring call vest, drowse.
Yeah, by the way, this guy activates this coding thing with and deactivates it with drowse. So everybody does their thing there, just that you're not confused. Yeah, so I think this is pretty neat, but you can also, for example, select code by semantic entities. So let's check that out.
Take past state blue crunch, drowse.
Okay, what you might have heard is blah, 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 state crunch or so. And what he actually meant was take everything until after the statement that is marked with a K. And state crunch is the statement scope, and crunch is Handsfree coding speak for K. And what I think is astonishing here is that you don't have to, in your head, like think about, okay, I want to select everything until after the function. Now, what line is that, and what line am I in? And now I have to grapple the mouse and move everything from here to there. You can just say, okay, I want to delete this function, and then you talk about the semantics, and the thing just does it. And for me, this is a game changer in coding, because it relieves you of very much busy work and syntax crap that you just have to do because someone invented a keyboard 100 years back. Now, that's basically the coding part. For the rest, I'd like to talk about the really cool stuff that you can do in your spare time. And one of them is voice control or noise control. And I just want to mention that Parrot is a super awesome tool that lets you do exactly that. So you can basically noise control your computer with that. And the specialty with noises is that you don't need a language model or anything. It's just or cluck, cluck, you know, and it's super fast to recognize. There's little context to consider, and therefore you can achieve latency well below 50 milliseconds. And maybe you already know what I'm getting at, but before we get at anything, that's basically the workflow with Parrot. You record sounds, so you're just sitting there for 10 minutes and go like, and when you've recorded enough of them, then you train a model, and then you can just map sounds to actions. And the cool thing is you can do stuff with Parrot, I guess, but I've never done that because I use Parrot with other software, specifically with Talon, because you get models that are compatible with Talon, and that means you have custom noises for your Talon grammar. And I just referred to the cool stuff, and the cool stuff obviously is gaming. And I'm not talking about Morhun here. I'm mentioning that because I actually have a Morhun slide, but I kicked it out because when we're talking about games, I
Catwoman now.
talk about cool games. So I'll just explain what you see on the side. You see that with my mouse, I control the direction. With my eyes, I control the camera. Tongue out means dive bomb or duck. Raising my eyebrows means run. Is the grapple gun. And now I can just glide around, and it's pretty accurate. So I'm just yeah, gliding on the corner, going back up there, now selecting someone to taste my boost. Yeah, the clicking sound, by the way, is kick and punch. Yeah, I'm just choosing directions with my mouse and kick people. Puffing my cheeks means special attack, by the way, and pressing my lips is the counter move. So that's here. Stunner. Yeah, I also have speech commands for attacks that I don't use that often, like the stunning attack. Yeah, and I think I'm just wrapping up the compound here. Claw. Now again, notice that some of these movements are pretty tightly timed. And it still works out because noise control is really pretty nice. Yeah, and that's it. So I'm just moving up the building again and see what I have accomplished. Yeah, which is basically increasing the potential interest in future hands-free coding talks. So that's the demo part, and I hope you are sufficiently hyped. Thank you. To sit a few minutes here, because the rest is basically slides and me talking and giving best practices. But I hope you have taken away that the interfaces that you have are not actually, you know, this is not a disability accessibility thing. It's really cool stuff, and the interfaces are so precise and snappy that you can, for all, basically in all dimensions that matter to me, do stuff that Batman does. And by the way, I have posted a link at the bottom to my Twitch, which doesn't exist yet, but I just wanted to use the opportunity to proclaim that I want to stream Twitch stuff. So perhaps in the future I might be doing this. And I hereby swear that I will start this afternoon. So at the very least, you can expect a Wolfram video tonight. Okay, now let's talk about the setup, because we need at least 5 minutes for the next slide. The setup is, as you can expect, complex if you really do it full throttle. But the basic setup is rather simple. So obviously you need hardware to get your input, like a microphone. Then you need some software or basically some language model that translates that audio signal to text. And then you need a framework where you can define rule sets to do stuff. And I use Talon, but there are other options at every level here. Yeah, and then you need a grammar, and there are really cool starter grammars that you can just download and use right away. There are tutorials everywhere. It's really easy to get going, and this part here is freely available. So you can just download Talon and then have the wave-to-ladder engine. It's awesome and it's working. Try it out. But if you're really doing this professionally, then you probably want to get the best that you can get. And I personally use the Conformer engine, which is basically the one that you get when you support the developer of Talon with, I don't know, like $5, $20 something bucks a month. It's easily worth the money. And I also use Dragon because I sometimes have to dictate stuff in German for emails, for example, and therefore I have to switch between speech engines. Yeah, but again, you have different options for engines as well, and people sometimes also use web speech or stuff. Works. And you also have different options for the coding grammar framework. So, for example, Dragonfly or Castor are pretty popular as well. And now the thing is that you might be noticing for Dragonfly and the other alternative engines, there's nothing between the speech layer and the actual framework. And that's because I think that's mostly magic in most cases. So all these frameworks rely on something called Netlink, which is software written in the early 90s, and nobody has ever written anything like that. So that's really what is still used today. And the only one that bothered to build a native and basically, updated layer to connect speech engines with the framework for coding is the Talon developer, I think. So, I have 0 minutes left. So I hope you have 5 minutes more because I will need them. Yeah, anyways, this is basically the voice coding part, but you saw that we don't just voice code. We also want to use noises. So you also connect your microphone to Parrot and have a custom noise model for that, which you will then, of course, somewhat wire up with Talon because you want to use the noises in your grammar. Then you also have an eye tracker, which I have to use for the mouse movements in the game, for example, or for controlling my mouse. And then you can also wire up the eye tracker to other software because there are, of course, special software just for eye tracking. And they also sometimes have features that other tools don't have. For example, Parrot can be wired up with Project Iris. Specifically, I think that's what the developer intended. So there are all kinds of connections between these tools. And a very important thing that I think is super awesome is facial recognition, because Mac has accessibility features that can be used natively in Talon. So you could use that if you had a Mac. I am a Windows user. So what I had to do was basically buy an iPhone, buy Kinetic Mouse Live, and then wire that up to my Talon grammar, which is super expensive, super convoluted setup. But this is what I use, and it's working pretty nicely if you get it to run. 1 second. Now, there are tons of upgrades that you could use, just that the person in the background is using a so-called steno mask, and people are actually using that for dictation, for example, in noisy environments. I've never used one, but they are supposed to be great. Now, just to illustrate my setup, this is how it evolved. I started with my notebook and then just used a Bluetooth headset for voice coding, basically the one I'm wearing right now. And that was cool. I then used an eye tracker and bought a PC, also eye tracker there, and connected everything with the Bluetooth headset. That worked nicely because I could connect to both devices at the same time. But the thing is, Bluetooth is just not cool when you're listening to music. So I bought a professional microphone like the one I'm using right now for this talk. But the problem is a wired microphone is difficult to use when you have to use a wheelchair. So I also plugged it first into the, I had this what is it, sender receiver unit thing, which I plugged into the computer, but then I could only use it on one computer. So I bought an audio interface and then plugged it into both machines. And then I thought, okay, well, this facial thing from Mac is nice, but I don't want a Mac. So I bought an iPhone instead, which I don't know what to do. So I have an iPhone now, and I use that for facial recognition. And it kind of worked. I mean, you saw Batman, and I think Batman can explain that. Yeah, now for the last few minutes, a few pitfalls and challenges just to get you up to speed with best practices. First, of course, microphone, super important. That's basically where you spend your money, because a better microphone means higher efficiency for you and less frustration. Then environment should be not noisy, because noisy environments are obviously difficult for the recognition. And you should also always try to work on your pronunciation and define a rule set that avoids misconceptions on the part of the recognition software. Then things that are difficult is, from my point of view, multi-language support. There are efforts to make this more feasible, but right now I always feel it's super complicated to get stuff working in English and German, for example. And one aspect is that English is basically the number one language used by everyone, and therefore all other languages just have poor support for basically anything. Then stability of the eye tracker and basically also the software that you use anywhere. It's pretty stable, but when you really depend on this working and we do not have any means to use the keyboard, then it's a problem, because from time to time stuff just crashes. Yeah, and then just workflow and anger management are also important parts of hands-free coding, because you will get people whisper into your microphone. Super funny, by the way. Yeah, then you will get enraged and you have to stay calm, because as you saw with Scrub.1, just talking something like thank you doesn't help at all and makes you even more mad. So even when your insides are boiling, you need to stay calm. Yeah, then you need to find a voice in which you can talk for hours, because that's what you do all day long, every day. And you have to practice to for example, get efficient with commands and command chaining. Yeah, obviously should be obvious. Yeah, that's what obviously means. You are talking all the time, so beware voicing passwords and stuff. When you are wireless, you probably don't encrypt anything. So depending on what kind of high value target you are, this might be relevant to you. And when you're using continuous eye tracking, people know where you are looking at. So depending on what you do for a living, yeah, maybe consider turning that off from time to time. Yeah. So is this still worth all the hassle? Sounds super complicated. Yes, of course. Otherwise, I wouldn't be giving this talk. Because one, you can boost your productivity with this kind of software. Then it's super convenient because even if you use Handsfree coding just for parts of your workflow, you can relieve your hands from time to time. And that's just cool. And you can have more intuitive interfaces than you have without Handsfree coding. For example, the macro thing where I say run code and it just runs code. You know, you could, for example, have a foot pedal to enable voice commands and then just put the foot down and say run code, and then it runs code. How awesome is that? Yeah, and then it's actually also obviously an accessibility feature, and this can be relevant to you because people develop repetitive stress injury or cubital tunnel syndrome. You may do sports and then break an arm, a leg, or both, and then it's cool to know that this is there. And I mean, honestly, you are talking to your computer. This is just awesome. So I highly recommend doing that. Yeah, there are 1,000 resources that I can recommend. I'm not talking about them. Just click on the links on the PDF that will be online soon. If you're interested, read those blogs. Super awesome stuff. Also super awesome talks. The one from Emily that I mentioned earlier. But there are tons of other talks. I could give 10 slides like this because really super awesome guys in this community. And my closing recommendations would be, when you try this out, keep it simple. So try to do something that feels good for you and don't try to be efficient at the beginning. So just use something that is recommended to you and don't change anything on the workflow that was recommended to you until you have an opinion. Then keep it reasonable. So what I mean is, I've seen several demonstrations of Handsfree coding where people were talking about Handsfree coding and then clicking the slides with a voice command. And this is just asking for chaos to happen, because obviously when I talk half an hour, the thing will at one point or another misrecognize what I'm saying. So don't try to create workflows and then complain that stuff doesn't work. You know, the use case should make sense. Otherwise, Handsfree coding isn't the right tool. But you could, for example, use it to type class commands, commentary. Nice, my Akku is niedrig. But I think we will make it because we only have one slide left. Again, the final recommendation is just keep it in mind. So if you really are not interested, it's good to know that hands-free coding is a thing if and when you break both hands. Yeah, then I also wrote a Heise article on this, so please read that if you're interested. Yeah, and that's it. So please support the Talon developer. Try handsfreecoding.gi.de because that's the URL of the Gesellschaft für Informatik initiative on that. And join the Talon community and ask questions, either in the Slack or why not here, because I'm here. Yeah, and by the way, there is a mailing list for Handsfree coding, and you can witness the first mail to be sent over that list if you subscribe today. So please do that. Yeah, that's it. I'm only about 10 minutes over time. Thank you for listening. I'm ready for questions.